The rain was a bit upsetting, but I think pleasant weather is something that we always were waiting for, and it is here. Today, the sessions have got delayed a bit, so therefore there is a general confusion on exactly what is happening where, because it is happening there only, but it is happening at different times. So I will take this liberty of talking about launch on demand. While the panelists will come in. Other panelists will come in. On this panel, we have a very strong team. It is unfortunate that we have very little time for this strong team. We have the Skyroot, we have the Agnikul, we have the Galaxeye, all of them contributing as startups who were sometime back startups, but I think they have started up to a point that they are reaching some place now. But we also have a young representative, very aspirant, Sree, who would talk about certain things that at the moment I will not be able to introduce because I would want her to give us a surprise. We are waiting for Suar from Galaxeye. Galaxeye, of course, has very recently launched a SAR with UAV, and they are aspirants to do the SAR in space, but at the moment they are doing SAR in the near space. So SAR is SAR in any case, so I think they have done a good technology demonstration. And so has Skyroot done technology demonstration, and Agnikul, both of them. So we will hear from them certain ways as to how the launch in demand would be seen as a concept which I am going to be broadly talking about now. We were all sitting in a separate hall talking about the strategic space and how the future should be and how we should plan. Space being a fourth frontier, but I think it is still the forefront of the new technology which India has been in this domain for some time, but as far as defense is concerned, I think we are yet not there where we should have been. So therefore, if and when India goes to war, unless of course we describe that maybe India is already some kind of a situation where we can say that we are already at war. As far as space and cyber are concerned, these are standoff warfare, and this war starts much before any other war starts. The satellites of a nation start focusing on certain areas of interest. Satellites of certain nations start looking at certain analytics of certain area. The ISR starts focusing on gathering what is happening where, and then they narrow down to what intelligence they need from an area so that they can tell a decision maker that this is the situation on the ground. And once the decision maker understands that the situation where the ISR analytics are pointing out, at some point the decision maker has to decide what to do with that information. In that, either the target has to be kept under observation or the target has to be neutralized. So one of those things will have to be done. Dr. Dev, read in place of Suresh, Dr. Dev from Galaxeye. So when we talk about launch on demand, is that who is going to demand? And how is this demand going to be put out to the private sector or to the government to say this is what we need? Really speaking, launch on demand is a gap between what we have today and what we want to achieve. Or launch on demand is a reserve technology or the reserve stock that we can actually put into the space when either the failure has happened and we want to overcome that failure and certain amount of redundancies there, or there is a disaster or a national exigency which has happened and we have not been able to address it and we want our space assets to be spruced up. And if we can do nothing about this because we did not think about it earlier and we have not had the cost kept in mind and those budgets are not there for those kind of launches and that kind of a manufacturing and we don't have a lead time, nation has no option but to depend on the international cooperation and certain private, public, government space agencies who will come in, who are trusted partners of a nation, and they would start giving the services in space to fill up that gap in between. So, for example, if you put out a satellite and you expect that satellite to be functional, say, in a day or two's time, and you did launch it and it failed. There are many reasons of failure. But then how do you now cover that amount of failure? Because you need it. And you can ill afford in wartime these kind of failures, so those kind of redundancies got to be filled in. So therefore, when we talk about the ISR, I would first talk about the threats from the space. That ISR is something that we are looking for on ground, and space situational awareness is something that we are looking in the space and what are the threats to us from the space. So as a result, the ISR and the space situational awareness or space domain awareness are two ends of the spectrum where we need information as to what are the threats and how do we respond to those threats, or what are the opportunities that we want to avail to be more superior than our adversary. So these are the things that we need to talk about. So let's first talk about the threats from space. Is somebody looking at me as a threat? Or is there something else that I'm looking for, that some element from space will come and destroy us? So I will start with the youngest one, Sree. Do you think the space is a threat to us? And how?
Yes, sir. Thank you so much. I would totally believe the globalization and advancement happening would lead the space as a threat to us. Because, specific example I would quote, take the example of X-37B and Shengbang we're having. Recently, a company called LOD in India spotted maneuverable space plane going on in space, which can do RTOs, reverse missions, and reconnaissance missions. With such technology, the whole human and space technology can advance, but at the same time, the ability to be at a particular point on Earth and spy on the particular country and not be detectable, and at the same time have the capability to launch in a glide phase mechanism and not give enough time to perform the necessary action from our side to retract it or deteriorate it will lead in very dangerous situation for every country. In World War II, the country with air supremacy won the victory, but next time if it happens, the country with space supremacy is going to see the victory.
So, is there a worry for India today that we need to do something, or we should have already done something to make sure that our space is safe for us? Or do you think adequate measures have been taken already? Or if it has not been taken, what do you point at that we should have done or we should do immediately?
Okay. I wouldn't say we haven't done anything yet, but there's a long way to go. With IIF incorporating ISF and a lot of policies being incorporated that advance the space warfare, we are in the process, but a lot of investment or a lot of dedication on R&D should be put into in this domain. And but yes, privatization will definitely play a very important role to accelerate this. That is one thing we will have to initiate and accelerate at a faster pace to match the capabilities existing of our advisories.
Okay, thank you very much, Dr. Galaxeye. Firstly, the name of the company itself is very exciting. What did what did come to your mind in your company to name it? What was the vision that you created the company? Where you are headed today? How much you are successful? Are you looking at ISR as your domain? Where do you think you should land up in, say, next couple of years, and you can give your own benchmarks? So, give us something about this startup to already started up with.
Okay. So, I hope everybody knows about Galaxeye. If you are not aware of, in a couple of lines, we are a company which are developing multi-sensors across multi-altitudes, from drone to satellites. So here, this is the multi-altitude, and multi-sensor means we are putting SAR as well as multispectral sensors in the same satellite. This certainly helps in ISR because, as you understand, when you are looking at an Earth and trying to decipher certain information, optical is very easy to decipher and understand. But the challenge is during fog, during cloudy season, during rainy season, optical data doesn't give you full information. Whereas SAR gives you the nighttime information, but the challenge is interpretability, not where everybody can interpret very easily. So, if we take both the data together and fuse it, that's what we are experts in, and provide the information with respect to surveillance, intelligence, announcements, whatever you want to use it for, this becomes much more interpretable and useful. So, as a startup, we started with this thought process. Of course, we are very focused on ISR applications and especially looking at Indian defense to work very closely with them and develop use cases which are going to help them in their ISR activity.
Thank you very much, Dr. Dev. And talk about ISR a bit in detail a bit later. But at the moment, I want to talk to Saraniya. Very recently, they've had a launch, which is a technology demonstrator, very unique, with the aim of bringing the cost of launch lower and maybe subsequently very affordable. And therefore, they are looking at themselves, we call the SpaceX of India. But I think this is only a beginning of it. So please tell me, what is Agnikul's overall ambition and where you have reached, and how are you going to contribute to launch on demand, and how do you think launch on demand is going to materialize? What is the whole process, launch on demand, that you're looking at? Who will ask you to launch? What will you launch? How much will you launch? How many places can you launch? What is the capacity that you think you could launch? So, tell us something about your company, your technology demonstration, and ultimately your objective, and would you be the SpaceX?
Yeah, myself Saraniya. Basically, in Agnikul, we are trying to build a small satellite launch vehicles. So our aim is to target the market where, because of all the technologies which is getting developed, all the satellites are also shifting. So we are trying to target the market which is having lower mass, and they need not wait for longer time for the launch to come. Because generally, if the vehicle is very big and the payload capacity is big, generally the small satellite people have to wait longer so that they get some space in the bigger launch vehicle, and then they are able to. So we are trying to reduce that. We are trying to target the small satellite developers whom we can whom we be helping to launch and reach the orbit as soon as possible. So that is the objective of Agnikul. So we are targeting around 300 kg payload for a lower orbit. So this is the objective for Agnikul. And we have recently successfully we have completed our suborbital vehicle launch on May 30. We try to demonstrate the technologies which we are going to use in our Agnikul, that is the orbital vehicle. So in our orbital vehicle we have two stages, stage 1 and stage 2. We try to derive all the technologies which we are going to use in our stage 2 to
to make this adaptable. So, for example, our propulsion system, our controlled flight, and all our avionics software system, which we will be using for our stage 2, we try to rewrite that and then do a technology demonstration. That is what our advanced orbit is doing.
So, from sub-orbital to orbital is a journey which yet to be undertaken. How confident are you that you will be able to undertake that journey? And how did you ever think that these small satellite manufacturers and small satellite operators and those people who are the stakeholders will be demanding launch of small satellites? Do you have a capacity in mind that you would be asked to launch so many small satellites? Do you have a scaling up model in your mind that at some point you will be asked to launch from a vehicle, launch from sea, launch from an aircraft? Do you have a broader vision, or you're just going step by step?
Definitely there is a broader vision. When we started off itself, even our tagline says, launch from anywhere, anytime, that's how our tagline also says. So anytime basically in the longer run, how we are looking is, we'll be able to launch one vehicle once in 2 weeks. That is how we are trying to scale up, or that is how we are trying to build our production. That is regarding that is all about how we are planning, and all we are targeting the communication right now. Even now, in many rural areas, we are not able to get internet, so we are expecting more and more satellites to be launched for the communication system is to be established even in the rural areas.
So communication and of course other use cases. Because of course satellite is a satellite, and it will do what it was meant to be doing. Because you are only the launch segment, so you can't decide what satellite you will launch and what you will not. Coming to Skyroot, Mr. Shireesh is here, Director of Business Development. Again, the vision of Skyroot, and how do you envision your contribution to launch on demand? Do you think service on demand is more important than launch on demand? And if we call service on demand launch on demand, what is the lead time that you would need to get a service up with that kind of capability that you have in mind? So please introduce your company a bit, why Skyroot and what Skyroot is manning, and how would you contribute to launch?
So, Skyroot is the India's leading private launch vehicle company, and we started in 2018, and we did our technology demonstration in 2022 November. So it's close to 2 years that we have achieved our technology demonstration, and very soon that we will be going for the orbital launch that we intend to do before the end of this year. That's the plan. And we are also a startup which has raised the highest capital among the Indian space startups. We raised close to $100 million, and we are having a manpower of more than 300 people with 4 different facilities based out in Hyderabad. And we have established the capacity to produce 1 launch vehicle every month as of now what we have. And we are looking forward to expand this facility so that we can have even better cadence. Coming to our launch vehicles, we are a solid propellant launch vehicle, fully developed in carbon composites. One of the main reasons for us to choose this particular propulsion system is because of the very less moving parts and also faster to the market. And we have the carbon composites as a structure that gives quite a higher thrust to weight ratio. And our upper stage, we have something called as an orbit adjustment module. And for the Vikram series, on the Vikram 1, we go with the liquid propulsion system, whereas for the Vikram 2 and 3, we go with the cryogenic modes. And with this orbit adjustment module, we can position the satellite where exactly it wants to be with an accuracy of 0.02 degrees. That is what we can support for the launch on demand. And coming to the launch vehicles, The whole Vikram series is of upgradable architecture, so we designed it in such a fashion that the systems and the subsystems of Vikram 1 can go to 2 and 2 to 3. So the whole launch vehicle integration can happen within 24 to 36 hours. We will be able to launch any satellite that we require to be in space. So it is not just important for the defense applications, it is also quite important for the commercial applications. As Saraniya was mentioning, that smaller payloads that they need to queue up for the launch until the primary satellite is ready for the launch. On the other way around, okay, if a small satellite is not ready by the time of launch, if they miss the launch, for the next launch again they have to wait for a year or so. So even on the other side of it, it's quite critical. So the real the flexibility is something which is very important for a small satellite, and we believe that we can address that solution.
Shireesh, thank you very much. I hear from my left and right small satellites launch capability, but I haven't heard much about the reusable launches, the reusable technology. You can reduce the cost of launch, of course, many ways, and of course, in your technology, you are trying to also reduce the cost, because we have more number of players and more number of modes of launch. How and when do you think you would demonstrate the reusable capability? But I would not ask you first. I will go to Sree. Why do you think we need to go reusable? How does reusable technology pose a challenge? How far is India from getting this technology, and what needs to be done about it?
The reusable technology will reduce the launch of cost by almost 80 to 90%, and also increase the frequency of launches to even bi-weekly and daily. This is very important for the future missions we are having. One important thread I would add to this point is the launch element requirement is very high to mitigate the threat of hypersonic missiles, which is very advancing in all the countries, and these are very hard to intercept. To mitigate this, one asset all the countries have is this basic asset of SATCOM and communication technology. And to establish that for ours, we have to launch in very, very frequent phase. That is only possible by establishing this reusable technology and making it more and more affordable. Currently, many startups, and including ISRO, like the recent Pushpa has demonstrated the successful test for the third time. We are in the process of developing that technology, but we have to accelerate and bring it into a successful product at very fast pace and perform the launches in a very frequent way to mitigate all of these challenges in space warfare.
So, Sree, are you saying that India could very soon have a solution to give us defense from the hypersonic threat? Is that what you're saying?
Potentially, yes, sir. We have the potential to do that. We will need collaboration and inclusion of every department and every individual to be able to make it. I can say that we do have the potential to make this, mitigate this threat from India.
I think we need a special session for that, and I think all through the day we're going to have a number of discussions on the defense track. We have on tryout, we have on the Space Force. I will be very happy that if you could contribute there about how to mitigate and take care of this huge threat from the hypersonic missiles. So, Skyroot and Agnikul. Anything on the reusable technology, where you are, how you would do it? And this is the last question I'm asking, and I won't ask Dr. Dev because I'll leave it to the audience to ask him. How are you going to completely interface your ISR into the Indian ecosystem of ISR for decision making? So, a short, reusable, integrated frameworks.
Regarding feasibility, definitely that is there in the plan for Agnikul. We have also started to do a trade-off on the various reusability there are different techniques you can bring back the vehicle back. You can use a parachute, how the SpaceX is doing, how Rocket Labs is doing. There are different views. So reusability, as she correctly said, it is going to be the ultimate goal because that will help us to launch as frequently as possible, as well as that will also bring down the cost significantly. So we also have to do a mass trade-off because how much we are going to actually gain or what is the cost benefit we are going to get. That also has to be studied, and we are maybe not in the first development phase, but definitely now we are already trying to incorporate few of the requirements which will be used for the reusability of the launch vehicles.
Shireesh, Agnikul.
So we are not into the reusable yet. Like we are in expandable launch vehicles. And like how we can contribute to the launch on demand is we can have all the rocket motors inventory. So any requirement that comes within 2 days, we will be able to integrate the whole launch vehicle and launch those satellites. But being said that, however, for the mitigation on the preparedness of it, like we need to have in the satellite study and we need to have an inventory of it. So we can back up that requirement within 24 to 36 hours.
Ladies and gentlemen, I am getting the impression that launch on demand is at the moment a very elusive concept. A lot needs to be spoken and a lot needs to be done towards that. We cannot cover our inadequacies in space through a concept of launch on demand which is not fully understood or fully imbibed by our ecosystem and more so by the private industry. Galaxeye, of course, would look at that we need persistent ISR. And you also have invested in HAPs technology. So this is just a piece of information that I'm actually, because we are running short of time, I want the audience to interact with the panel. So therefore, I'm not asking questions, but I'm only giving certain introductions that launch on demand is extremely, extremely important, and most of the militaries are speaking about it. So collectively, let's talk about it. Let's see what the audience wants to ask and what the audience wants to contribute towards launch on demand and the apps per se. The floor is open.
Launch on demand is important, as they say. But along with launch on demand, which I think I asked your team in Sree, instead of a static launch, can you have a mobile launch pad? So, in the operational area, where we go, as per the demand, as per your mobile launch pads, that will be a game changer. So, can you do it?
Definitely, sir. We are actually planning to do everything mobile. If you can see, even our facilities are made in such a way that it is container. Wherever we are asked to move, we will be able to move. Even in Shireesh, our mission control room, even the skids which we have laid for the launching for the suborbital vehicle, everything is moved. So we even call our mobile launch pad as guns from wherever everyone can be launched. So all our systems, all our facilities, all our launches are planned in such a way this moment. It can be taken anywhere and it can be launched.
Yeah, please.
I have just one question about the recovery aspect. Right now, the recovery aspect of the rockets. For heavy lift launch vehicles, it is quite difficult to land the rocket propulsively or by any other method. But for smaller size rockets, why isn't parachute recovery with soft landing on water explored as an option? Or is it being explored currently? That is my question.
So, is there a question?
My question is parachute recovery of your rockets being explored with international soft landing water?
I don't know, I mean, if you have a theoretical answer, unless you've already actually explored.
Actually, as I said before also, we are thinking of an recovery as you said, parachute rocket launches, and then SpaceX, we manned it with we are exploring those options. So based on our advanced data only, we will be able to come up with the exact configuration which will be required for that.
No, but I thought that usability was recovery as a technology. So, but is there any difference between? So you could build more upon it. That reusability and recovery are spoken differently or are spoken the same way?
Can I answer that?
Yeah.
So, recovering the stage, okay, coming back to the launch pad as SpaceX is doing, that is one side of it, and his question is more towards, recovering within parachute and something like that. So, the stages, like when we launch a rocket, it is in the high seas, and the impact point where it will be falling. Okay, so from there, recovering it, okay, and refurbishing it would be much costlier than our minimum. So, yes, by parachutes you can recover, but the expenses in doing so is much higher.
I would like to add a point to that, sir. We are also looking actively into space things, which reduce the G-force during recovery. The product itself being reusable is one, and at the same time, the space assets that are recovered can be recovered at a very safer rate and at a very better condition because of this less G-forces, which is actively being pursued at the moment. I hope that answers your question. Yes.
Any more questions? Because after all, now we have ISR as a big field which is open. ISR is not only the ability of a satellite to go over an area, but ISR is the ability of what comes down on ground for decision making. What does, in the military parlance, what does a commander see? You have a question on the ISR, or you're still on the reusable, or on
I have a different question for Skyroot.
For?
I have another question for Skyroot Aerospace.
Okay.
Sir, so since you are developing a new rocket that is becoming, so why didn't you choose the first stage as liquid propelled rocket? Why did you go with the solid? Was the intention to make the launch easier, or like did you face some problems in implementing the liquid propulsion system first stage?
So it's a conscious decision that we have taken. Like the first thing is we want to be faster to the market, and also choose a propellant that has the higher reliability in terms of it. So these are the two things where we have considered. Where we have considered to go from the solid propellant.
And like, if this rocket gets successfully launched, do you plan to implement like hybrid and liquid propulsion systems in your next stage?
So, however, like as I mentioned, the first three stages are solid propellant that are launched with the first stage. Now, Vikram 1 is liquid propellant, and Vikram 2 and 3 is of cryogenic.
Anything on HAPs or ISR? I'm looking at Dr. Lake to contribute towards the larger understanding of the gaps in the ISR and how launching demand can cover those gaps on ISR and how much time.
I think when we talk of launch on demand, HAPs is the best platform because it's more like a very high altitude and imaging capability like satellite because we are looking at the Earth somewhere around 20 to 25 kilometers. So launch on demand, especially for disaster or any counter-insurgency kind of scenario where you have to immediately fly or take the images, in my personal opinion, HAPs because launching is easier, availability is easier, and imaging can be faster, and it can lighter at the one place, and it can capture the images and deliver it. Other gaps wise, as I was saying, if you look at currently both the images what you get is from different platforms. So synchronization with respect to the temporal time as well as the look angle is difficult. And hence, interpreting both of them together and getting a valuable information at the same time can be a challenge. By fusing the image and then using that fused image for interpretation and analysis. And we are not only trying to provide the images, we are trying to provide the softwares to analyze those fused images so that your object, which is AI based, and you can do the object identification and classification with the help of those softwares and the fused images which are.
So just to generate a debate, not that I'm suggesting it, but to generate a debate is that don't look at launch or demand that the rockets will go up and satellites will get into orbit and then you will have all of a certain capability come up. Don't do all this. Just do HAPs and then you cater for that. Your asset comes down and it is reusable. You just change the payload and do whatever you want to do with. You can use it for comms. You can do it for any other purpose. You can send it to any direction that you want. Will that be a good theory? In launcher demand, or we are again looking at the reusable launchers being pushed into service, the satellites not available but quickly being assembled, which don't really open up and provide the service on time. So the satellite operations per se should remain permanent capacities, and launcher demand should be seen more as apps operation. Would that be a good suggestion?
Exactly, sir. What you said is absolutely right, because sometimes you may need to put some AIS or thermal images on top of the apps and put these image capture. So you can bring it down as per your need, load those sensors and launch it back again. So that's certainly another way of looking at launch on demand. It's not only when you require it, you can use which kind of measure you want to use to capture your data and use it. That can also be done.
Air Marshal Baby sitting here, and for the last 2 years we've been talking about the near space. The description of near space is HAPs, and this description of near space is also not really HAPs. Now that we are talking about launch on demand, the understanding with a little tilt of affordability, secondly the time and the flexibility of it. Before I ask Air Marshal Baby, do the Skyroot and Agnikul both feel that you are not going to be part of launch on demand because it is theory, it is going to remain theory, and as it will remain theory, so as far as this space operation.
So indeed, when we are speaking about the launch and demand or the distribution plans for something of that magnitude, we need to have multiple solutions. It's not just one particular solution. It's not just HAPs or it's just launch and demand where we put the satellite. So the combination has to be where we have geo satellites and MEO and the LEO and VLEO, and in combination to that HAPs. And for the LEO or something where you want to put satellites into the space, again you need to have multiple options of transporting this. It should not be just a reusable launch vehicle or something. You need to have an expandable launch vehicle where you have the inventory ready, and it could be in sea launch or it could be in launch from land or launch from air. So having multiple options ready for a scenario such as this would be more helpful.
Not just because it looks good to have multiple options, or it is practical?
It's a necessity, yeah. It's practical and it's more of a necessity from the defense side to having multiple options. It's a preparedness.
Another idea that I have is, of course, and only to generate a debate, is invest in space, have dual use capabilities, and you see that how much Earth observation, which is not strategic, but can be brought into the box of being military grade and put to service, that is service on demand, to say, at the moment now stop watching all that we were doing before. We don't want, now we are at war. So you have the ability of a military grade, now get into this box of military grade and start providing service to us. Could that be a service on demand where more beams are open? More beams are open in certain areas that they were not required earlier. Open a beam, also there is a cost requirement. Could we look at those possibilities and also continue to have the strategic support from our allies, from the international space agencies and the governments? Could we do that, or we need to build an indigenous launch on demand capability, which is purely meant for defense?
So launch and demand is something which has to be in sovereign capability that the country should have. Okay, so this is in essence working towards that. And coming to the next question with respect to satellites, like EU observation and doing commercial applications and all of this, moving towards the defense applications. So always they are of dual use. Okay, whatever data that is being collected and that could be parallelly used for both the defense applications as well as the commercial applications.
So that needs to be worked out in detail how the switch would happen, right?
What I wanted to add to what you said, certainly that is a way to go for dedicated ISR activity for air defense forces. I think SBS program is going to be one of the initiators in that. However, that's not launch on demand kind of thing. So we need to bring it under the purview of, we can increase the purview of SBS and we see how HAPs and all these things can be brought also in the purview and focus only on military grade kind of applications and cater to the defense needs.
So are you saying organization like DAPAC could also be looking at HAPs on demand?
Yes.
Is that what you're saying?
Yes.
And okay, interesting. I will go back to the audience before I conclude, because after all, it is for you, the panelists in here. We have 5 more minutes. Okay, General Manjeet.
So, Mr. Dev, you spoke about the SBS programs. I'll just talk about ISR, space-based surveillance. Now, we were talking about gaps in our surveillance. So, 3 things I would like to look at. One is the depth, the coverage, area coverage, if we are looking at. What is the area? Keeping into the swath of the satellites. The other thing is the revisit time. So presently our revisit time is 3 to 4 days. So how we will reduce the revisit time? And the third thing, which is a very important factor, is the resolution, what we are looking at, especially both panchromatic and maybe the multispectral domain. So what is the resolution which we are looking at is also very important when we look at space-based surveillance, and when we talk about the space-based surveillance program or the SBS revised program which is coming up. These are the aspects which bring a lot of importance and emphasis.
So you have rightly brought out the 3 points which are important for ISR activities. So one is revisit, one is resolution, and third one was area. Right. So in fact, in my opinion, one of the best way to start is identify what are the use cases and for what kind of resolution is required, but because not for everything you may require 0.2 or 0.3 kind of resolution. Somewhere you may require a reconnaissance of a bigger area with a lower resolution. So if we can have those metrics and then fix it up. Regarding revisit, one thing which I can suggest is that revisit, everybody has a revisit time as per that. So if you are increasing the constellation size in SBS, then your revisit time comes down. And even if there are gaps, you can always cover it up with HAPs kind of thing, where you can fly the HAPs immediately, cover up for those blind spots or blind dates and capture those for data, because the resolution will be of HAPs will be very similar to a high resolution satellite, somewhere around sub-meter resolution, and the coverage can be as per your need. So if you change your altitude, your coverage can increase a little bit. So in my opinion, a use case based matrix is very much important, so that everybody knows what kind of data is needed where, what is their revisit time, what is their resolution, and accordingly identify these satellites which can answer those points and or provide data for those. And where are the gaps? Wherever there are gaps, you put the apps. That's how I will like it.
So, My request is to General Bedi that we will be talking about the near space. So how does the launch on demand and HAPs theory that we are talking about, how do you think it can be made more practical and responsive for preparing for the battlefield or preparing for it?
Thank you, sir. I think what I understand of launch on demand, where the gap is that probably we think that something is going to be asked on demand about which no one knows what is going to be demanded and in how much time am I expected to launch. But whereas I think we need to create a system where generally it is known what is required or what is going to be demanded. And if I can draw an analogy, it is like ordering something from Amazon. More frequently something is used, is more quickly available. If it's less usable thing, then it will take more time. But it is known that whenever I order something, it will come. In what time frame will it come? Even that is known. So that is what is launch on demand. It's not that you're wondering that I can demand today anything, okay, launch this satellite for me with this capability and quickly then put it together and launch. That is not what will happen, what I have heard. So I think a decent time, framework industry has to know that, like military or anyone, what are you thinking? What are you likely to demand? So that the basic infrastructure and ecosystem is kept ready. And now when I demand something, and something is available to launch on demand within reasonable time frame. About HAPs, filling gaps of satellite, my only contention is that HAPs are always going to be in your sovereign space. So the coverage they provide you is limited only to that much. Like if you are looking at, let's say, China, 40 degrees north latitude, HAPs is not going to help you. I mean, they will always be in the sovereign space of someone else. And
could you also speak about the balloons which were discovered after we started speaking about the space?
Yeah. Absolutely. So what happens is, there is a serious litigation about this covering, but yes, for quite a bit of coverage, I would say that in the border areas and things like that, it can be made up. There is no doubt about it. It's not easily targetable, while targeted, right? So we are not discounting it all. We are the proponent of this capability, but capability needs to be kept in mind. What is it going to give you? About resolution, you are right. What happens is we somehow at times build that fetish for smaller and smaller and smaller resolution. You need to move from searchlight kind of operation to torchlight. Where you need broader area to firstly detect that is there something available. You probably don't need very fine resolution. And then when you know where you exactly have to look, you need fine resolution. So you can economize on resources to quite an extent on this.
What you suggested exactly that's what I was suggesting, even for launch on demand. If we have this metrics kind of thing ready, we know which kind of satellite needs to be launched for which kind of activity. If that activity requires a higher resolution, is that satellite ready or not to be launched? So those kind of things will certainly start falling in place when we have this kind of metrics ready, that this is the basic things we should have ready for this kind of activity. And coming to HAPs, you are absolutely right, it's mostly on the sovereign state, but what advantages the SAR carries is it has inherent capability of looking sideways. So the look angle increases as a respect to larger, even if you are flying on the border area, your look angle increases, so you are going in depth to the enemy territory and having a look at it.
At the cost of clarity. You see, naval operations and oblique angle, we all know the limitation.
Very useful. So at least it can give a basic idea, and then you can start looking at different activities or different options to go in detail and identify.
Thank you, David. Actually, we run out of time. We can meet over a cup of tea because the lady is already looking at me. Very hard. It was just part of my script to say that if we have 4 S's in this, Suvash was supposed to be there, but the one Savan has come in, and that S has dislodged Suhasan, brought Dave into it. So thank you very much, Dr.
And what else is waiting here? What else is waiting here?
Thank you. And there is another S standing there, and who's going to dislodge all us. Thank you.
For the structures needs that way. Ed, thank you so much on that note, the entire panel for the highly insightful and interactive sessions, I would say. So with this, we move ahead with the felicitation ceremony and request the chair, Pannu sir, to kindly felicitate all our panelists. We'll start with Ms. Saraniya.
Yes, look here. Thank you.
Dr. Debjyoti. Mr. Shireesh. And Sree. Young 23.
Yes, look here.
Indeed, honor to have Sir Pannu sir always with us to take care of. I think so many avenues. We can have a good picture quickly before we dive into the lunch.
Yes, look here, sir. Thank you.
Thank you very much. It's time for a short lunch break because we will resume not after an hour, after 30 minutes. Because there's already a delay in every session. So after 30 minutes,